Okay, good morning, everyone. Hope you had a good weekend. Today we are covering, this is our last week before spring break, right? Next week is spring break. So we're going to cover two topics this week. We're going to finish up what we were doing last week with the synthetic division and using that to help us factor, and then ultimately sketching polynomial functions. And then next class, we're going to start the rational functions, which is the next type of function we need to be able to sketch. Then we'll have our spring break. The only thing that's due this week is on the 8th. The homework for 5.6 is due. And then right now, I don't have anything set to be due. Let's see, we come back on the 21st. Right now, I don't have anything scheduled for the 21st. Let's see how class goes on Wednesday. But yeah, enjoy your break. That's the whole idea, right? So we should just have this homework assignment, and anything else will be sometime later in this week of the 21st through the 25th. Otherwise, are there any questions right now before we start?
But for your solution videos, were those two homeworks yesterday?
Yes.
They weren't the right videos.
Yeah, somebody let me know something about that. And I guess my response to that is, if you have any questions about the homework problems, to please reach out to me to get help. You know, you have my cell phone number, you can text me. I'm at home a lot. So I can always meet you on Zoom if you want to go through any of the problems. I'll take a look at the videos and see. I know I don't have homework solution videos for the whole semester. I know that. So unfortunately, I haven't been able to get those all made in time for you to be able to use them, but I might have some more time. We'll see how things go. But please reach out to me, come into my office hours for help. And then of course, you know, you can get tutoring through the math lab online through Zoom. Just check the syllabus for links on that. Any other questions or comments? Okay, well, let's get down to business. So the way that we're going to do this, I thought what would be the most useful today, because we've already established all the theory, right? Like the techniques are all in place. So really, it's just a matter of what types of problems are you going to see? What should you expect? So what I plan on doing here is working through the homework assignment that's going to be due in 2 days. So, well, I should say tomorrow. It's due tomorrow night at midnight. So I'm going to work through the homework assignment. Your problems will probably look different than these, but at least it'll give you an idea of what to do. So I'm going to work through those, and then when I get to the end of this, what I did is I pulled 3 problems off of last semester's exam. And these are the 3 problems that I asked that had to do with polynomial functions. So I figured we would go through those, so you kind of get an idea of what I ask on a test. All right. So let's start off. If you need any clarification on what we did last time, please, as we're doing this, you know, let me know, because I'm going to assume you kind of understood what we did last time. And it's up to you to kind of stop me if you're like, whoa, I have no idea what you're doing. So there's some terminology in here that I need to make sure you understand on the instructions. It says here, use the remainder theorem. Okay, well, the remainder theorem was just, all it is remember when we did synthetic division and we were hoping to get a 0 here at the end of the synthetic division? That number right there is the remainder. We did talk about that. So when they talk about the remainder theorem, using the remainder theorem to find the remainder when some function is divided by something else, that's all they're saying is use synthetic division. That's basically what they're doing. And then we're supposed to use that to factor it, all right? Which again is what we had done last time. So let's just go through this problem. First things first, I have a polynomial function, right? And they are asking us to divide this by x plus 4. In other words, they want us to do this divided by x plus 4 and figure out what the answer is, right? So what we do is we set up the synthetic division over here. And we have to be extremely careful here because we have 4x to the 6th, so I'll put a 4 here. I don't have any x to the 5th, right, to the 5th power, so I have to put a 0. Then I have an x to the 4th, so I'm going to put the number in front of that, that's negative 64. And then I don't have an x cubed, so I need another 0. Then I have a 1x squared, so I put a 1, that's the 1 in front of x squared. I don't have an x term, so I need another 0, and then I have the minus 3. So those are all the coefficients. Does that make sense, everyone? Any questions on that? We're good? Okay. Now, what number is going to go on the outside of this? If I'm dividing by x plus 4.
-4.
-4. Good, -4. Okay, so now you just go and you play that game that we played before. We're going to bring the 4 down here. Right, bring that 4 down. We're going to multiply -4 times +4. That's going to be -16. We add down, we get -16. And then we multiply -4 times -16, which should be +64. We add down again, we get 0. -4 times 0 is 0. We add down, get 0 again. -4 times 0 is 0. Add down, we get 1. -4 times 1 is -4. Add down, we get -4. -4 times -4 is +16. And when we add down here, this will give us our remainder. Our remainder will be 13. Understand? So the answer, okay, the answer to the first part of this question, to find the remainder is 13. Okay, so that's our answer. Now, the next question says, or the next part of the question says, then use the factor theorem, okay, use what you just did to determine whether or not x plus 4 is a factor. So is it or is it not? Is x plus 4 a factor of this? I'm seeing Zane say no, right? Henry saying no. It's, yeah, no, because we need that number at the end to be a 0. If that number was a 0, then we'd say, yes, it's a factor. And that's when we would do this thing where we bring this down and we would write x plus 4, and then we write over here and we use these numbers. That's what we would do if this was a 0, but it's not. And since it's not a 0, we don't do any of this. Okay, so we're done with this first question. Any questions? Let's take a look at the next one. Use the remainder theorem to find the remainder when f of x is divided by x minus a half. Okay, we have a fraction here. Okay, so things are going to be a little bit strange, but let's go through and set up the long division. Okay, I have 2x to the 4th, so I put a 2. I have negative x cubed, so -1. I'm missing an x squared, right? I don't have an x squared, so I'll have to put a 0. I have a -8x, and then I have 4 by itself. There we go. The number on the outside is going to be, well, we're supposed to divide by x minus a half, so I'm going to put plus a half here, or +1/2. So we're going to have some fractions here, but I think things aren't going to be as bad as they look. Let's see. We bring the 2 down. Okay, half of 2 is 1, right? Half of 2 is 1, so that puts a 1 here. You add down, you get 0. 1/2 times 0 gives you 0, so I put a 0 here. Add down again, we get 0. Multiply here to here, right? We get 0 again. Add down, we get -8. Half of -8 is -4. Add down there, we get 0. So here we do have 0, right? Which is what we wanted. So the first question is asking find the remainder. The remainder is 0. Now, because it's 0, we can use that to factor this. And this is where we come back here and we write, okay, this gives us the factor x. And remember, it's the opposite of what's there. So -1/2. And then can somebody tell me what goes in this parentheses?
Is it going to be 2x cubed?
Yep, 2x cubed. And that's because we started out with the power of 4, right? That's what we started with. We divided, and I told you this first number, the power on it will be 1 less than whatever's here. Okay, good. 2x cubed, then nothing, no x squareds, right? No x's, and then finally just -8. So I could have just done this, put it a little closer here. Just go -8, close it off, done, like that. That's it. Done. We have factored it. Questions? Okay, next one. This is a different question. It says use the rational zero theorem. Okay, well, I did not tell y'all what the rational zero theorem was. Let me finish reading the question. Use the rational zero theorem to list the potential rational zeros of the polynomial function. Do not attempt to find the zeros. So all they want us to do here is to go back like to last class. Remember when we were doing, do you remember we were doing these two lists of numbers coming off the back number and the front number and then creating a final list? That's the rational zero theorem, is to create a list of potential zeros for the function. All they want us to do is come up with a final list. They don't want us to actually go and try and find which ones work and which ones don't. Understand? It's just making sure you understand how to make the list. So what I'm going to do is I'm going to take the number in the back, 11. I'm going to write it down. I'm not going to care about the fact that it's positive or negative. I'm just going to put 11. And then I'm going to put 121, which is the number in the front. Okay. These are going to be the top numbers, and these are going to be the bottom numbers of our list. Excuse me. And then I have to figure out what all the factors of 11 are first. And the 11 is a prime number. So the only numbers that multiply to be 11 are plus or minus 1 and plus or minus 11. And then for 121, well, let's see, we can do plus or minus 1, plus or minus 121. And what else goes in there? 2 doesn't go in there, right? 3 doesn't. So you could check with your calculator. Take 121, divide by 2, divide by 3, divide by 4, divide by 5. What you're looking to see is if you get 2 whole numbers. So anyone know what the next numbers are? There is a number that goes in 121.
11.
11. Okay, good. 11 times 11, right? 11 times 11, or 11 squared. So that's it. Those are the only numbers we have in the bottom list. There are no other numbers that go into 121 other than 1, 11, and 121. So now I create my final list. So I'm going to start by taking this first number and dividing it by both of these. So I'm going to have positive or negative, let's see, 1 over 1 is just 1. And then positive or negative 1 over positive or negative 11 is plus or minus 1 over 11. Okay. Now I move on to the next number. The next number was 11. Oh, I forgot the 121. Oops, sorry, 121. I forgot that one over there. So plus or minus 1 over 121. So I've done the number 1. Oh, you know what? Let me do something. I don't know why. Okay, so I've done the 1 over all 3 of these. Now I'm going to do 11 over all 3 of these. So when I do 11 over 1, I just get plus or minus 11. When I do 11 over 11, I just get 1 plus or minus 1, which I already have in my list, so I don't need to write it twice. And then when I do plus or minus 11 divided by plus or minus 121, that fraction reduces to be plus or minus 1 over plus or minus 11, which is 1 over 11, which again, I already have in my list. So this is my final list right here. I believe when you do your homework, they want you to type it in like this, like 1 comma negative 1, 1 over 11 comma negative 1 over 11, and then 1 over 121, negative 1 over 121, and then 11, and then negative 11. In other words, you don't have the plus or minus on the homework. You just put them, you know, put the positive one, the negative one, then the positive, then the negative. Questions there? Is this all pretty straightforward so far? Yeah,
Can we
okay.
do one more?
Was there a question?
Can we do one more?
I can barely hear you, I'm sorry.
She's asking if we can do one more.
Yeah, well, the next one is just like this, same thing. Okay, so again, reading the instructions, use the rational zero theorem to list the potential zeros of the polynomial function. Do not attempt to find the zeros. So don't go and then do synthetic division. We're going to do that in the homework, but just on these problems, they don't want you to. All right, so we take the number in the back, 12. We take the number in the front, 10, and we list all of the factors. So the way I do the factors, I always start with 1, because if you do 1 times the number, you're always going to get that number, right? So I do plus or minus 1, plus or minus 12. I like to space them out like that, and then I start to build up the middle. So 2 goes into 12, right? 2 times 6. So I can do plus or minus 2, and then I'll do back here plus or minus 6. And then 3 goes into 12 4 times. So I do plus or minus 3, and then over here plus or minus 4. But now I've made it to 4, right? 4 goes into 12, but I've already done 4. 4 goes into 12 3 times. So once these numbers meet in the middle, you're done. Okay, you're done. So there's my list so far. Now on 10, I do the same thing, plus or minus 1, plus or minus 10. Okay, 2 goes into 10 5 times. So plus or minus 2, plus or minus 5. 3 doesn't go into 10, 4 doesn't go into 10, 5 goes into 10, but I already have 5. So that's my other list. So I'm done there. Questions? Isabella, this making sense? Okay, good. Yes, Dominic, yeah?
Yeah, is it like, why are they spaced? I'm just like visually like, is it like,
I know there's space because if there's a lot of numbers, you want to give yourself room to meet in the middle.
Okay. Oh, okay. So you're going, okay, yeah, okay.
So I'm starting at the edges and then I'm trying to build it into the middle so that when I was here and I had 3 and 4, now I know I'm done because the next number after 3 is 4 and I've already have it on my list.
Yeah. Okay. So you were using both. You were just going. Okay, I got it.
Yeah,
I was just like trying to figure out what the strategy was. Like,
yeah.
But yeah.
Sometimes I give myself too much space and I have a big gap in the middle. Sometimes I don't give myself enough space and then I have to like redo it and give myself more space. So I like to always start with a lot of space between the numbers.
Okay.
And then, yeah.
Perfect. All right. Appreciate it.
Okay. Good. All right. Now this is the part I really hope that everyone understands. You're going to take the 1 and then divide it by each of these. Okay. And then you're going to do the 2 and then the 3 and then the 4 and the 6 and the 12 and divide by each of those. So this could be pretty drawn out. Let me do it down here. When I do the 1 over 1, right? 1 over 1, I get 1. Then I do the 1 over 2, I get plus or minus a half. Then I do 1 over 5, I get plus or minus a fifth. Then I do the 1 over 10, I get plus or minus a tenth. Okay, so I've done all the ones over those numbers. Now I have to do the 2 over all those numbers. So 2 over 1, right? 2 over 1, that's 2. I don't have 2 in my list, so I'm going to keep going here. Okay, 2 over 2, that's 1, but I already have 1 in my list. 2 over 5 is not in my list, 2/5. 2 over 10, what's 2 divided by 10? 2 divided by 10, that reduces, right? That's 1/5. And I already have 1/5 in my list. So I don't need to write it again. Okay, now I move on to 3. 3 over 1, right? It's 3. I don't have that in my list. 3 over 2. I don't have that in my list. 3 over 5. I don't have that in my list. 3 over 10. Nope, don't have it, right? So, okay, yeah, I realize this is tedious, okay? And this list is going to be extremely long. Okay, now 4 over 1. It's 4, I don't have that. How about 4 over 2? That's 2, right? And I have that in my list, it's right here. 4 over 5, I don't see a 4 over 5 anywhere. 4 over 10, what's 4 over 10? 4 over 10, that reduces to be 2 over 5. Do I have 2/5? Right there, I do, so I'm not going to do that one. And I'm going to keep going. 6 over 1 is the next one. I don't have a 6 in my list. 6 over 2 is 3. I do have a 3 in my list. 6 over 5, I don't have. 6 over 10, do I have that? 6 over 10, that reduces to be 3/5. I do have 3/5 in here. Okay, one more. 12 over 1 is 12. 12 over 2 is 6. I have 6 in my list. 12 over 5, I don't have. And then finally, 12 over 10, I'm pretty sure that's going to reduce to be, let's see, 6 over 5. I do have 6/5 in my list. So that's it. That is the complete list of potential. The big key word here is potential rational zeros, meaning if there is a rational zero, it's going to be in this list. So how many numbers is this? Remember, there's 2 in each for each one of these. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32 numbers in this list. So if we wanted to, we're not going to, we're done with the problem. If we wanted to, what we could do is start doing synthetic division with this 10, 9, 14, 27, 12, right? That's the polynomial. And then we could start using these numbers. We try 1. If 1 didn't work, we do -1. If that didn't work, we would go to half. If that didn't work, -1/2. And that, you know, and what we're looking for, what we're looking for is one of these where we're going to get a 0 there. If we can do that, then we will have factored it. So it looks daunting because you have so many potential things that you might have to try, but it's a finite list. Like, it's better than having 1,000 potential ones, right? Okay, let's move on. This question's different. Use the rational zero theorem to find all the zeros of the polynomial function. See, they're not telling us to make the potential list. They're actually asking us to use the theorem and they want us to factor this thing, okay? Factor it, break it down. So now we actually have to go through the whole process here, all right? So I'm going to start first. So how do I know I need to use the rational zero theorem? if you look at this, if you're trying to factor this right now, there's nothing you can do to factor this. Try it. Try it yourself. Well, yeah. 30. Well, this might go by grouping. I'm not going to do grouping though. I'm going to do the rational zero test. I'm going to do 76 here and 2 here. Ooh, 76. Let me do the 2. The 2 is an easy one. Plus or minus 1, plus or minus 2. There's nothing else there. The 76 is going to suck. We have 1 and 76. I'm going to give myself some room here. How many times does 2 go into 76? 38. Right, 38 times. Does 3 go into 76? So you literally really want to have your calculator. Let me grab mine real quick because I might need it for a little bit later. Somewhere around here.
It doesn't go into 76.
3 does not, right?
4 does 19 times.
Yeah.
4 does. Yeah, 4 and 19. So that would be my next one. 4 and 19. I really hope I gave myself enough room here. 5 does not go in.
6 does.
6, how many times?
6. Let me
6.
see.
Wait,
Yeah.
6.
Wait,
Wait.
hold on. Let me see.
No,
76.
no, I don't think it does.
No, yeah, never mind. I did it wrong.
Okay, that's all right. So 5 doesn't, 6 doesn't, 7 doesn't, 8. No, 9. 10 doesn't, 11 doesn't, 12, 13, 14. When am I going to stop?
At 19.
At 19. At 19. 7. Okay, 15 doesn't. Nothing else works. Okay, till you get to 19. Once you get to 19, but it's already on our list. Make sense? Now we need our final list. So one good thing is, you know, when you have this 1 down here, all of these numbers over 1 is just the original list, like the original, this top one here. So I'm going to just start with that. If I do plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 19, plus or minus 38. Oh, 38, not 36, 38. Plus or minus 76. Okay, that's just all my top ones divided by 1. And then when I do all the top ones divided by 2, right, instead, then you're going to get 1/2 first, plus or minus. You're going to get 2 over 2, which is 1. You have that in your list. 4 over 2, which is 2. You've got that in your list. 19 over 2, we don't have. 38 over 2. What's 38 divided by 2? I think that's 19. 19 is in our list. And 76 divided by 2 is 38, and that's in our list. So this is it. 2, 4, 6, 8, 10, 12, 14. There's 16 possible, right? Possible rational zeros. So now we have the pleasure of doing synthetic division with these to see if we can get a remainder of 0. So we put in here 2, -4, -38, 76. And I'm going to do one of them. Let's see if it works. 1, I'm going to start with 1 and try this. So 2 comes down, 2 times 2 is 2, come down -2, that's -2. It's -40, that's -40, and that is not 0, okay? So it didn't work. Oops. Sorry about that. That didn't work. All right, so now what would I try? If 1 doesn't work, what should I try? -1. I would go 1, -1, 2, -2, 4, -4. And I would completely stay away from the fractions unless you get through all the whole numbers, then I would move to the fractions. That's what I would do. So why don't I give you an opportunity now to work this yourself for a few minutes. And tell me in the poll if you get to a point where you have a 0 as a remainder. Okay. So everyone's going to be working, doing synthetic division, trying to get a remainder of 0. We'll take a few minutes on this, see how long it takes. So far, we have 4 people that have found it. Seven people have it done. I'm going to go 1 more minute. Okay, I think 12 of you got that done. So what works? Someone tell me so I don't have to waste my time.
2.
+2.
2, is that what I heard? 2 works.
Yes.
2, -4, -38, 76. Okay, so you tried 1, it didn't work. -1 wouldn't work. 2 worked. Good. Now, remember what I said about the test. On the exam, I promise you that if you have to use this method, that as long as you do the numbers in order and you avoid the fractions, but just put all the other numbers in order from, smallest to largest, I promise it'll happen within the first, like you're not going to have to go and do like 10 different ones. It'll be like in the first 4 or 5, no more than that. So that'll let you know that like if you go too far, like you've done like 8 of them, they're not working, something's wrong. Maybe you didn't put your numbers in synthetic division box correctly, or I don't know, something's up. But let's see here, 2 is supposed to work. Let's see, bring 2 down, 2 times 2 is 4, 4 gives you 0, that's 0, that's negative 38, multiply that by 2, you get negative 76, there it is. Okay, good, now this allows us to factor, so we can bring this down as x minus 2, and then the remaining part of the polynomial will be this, and notice, excuse me, notice that we started out with x cubed up here. So this should be a 2 in front of x squared. We should have nothing in front of x and then minus 38. That's where we are so far. Now, you might say this looks completely factored, but notice that on this one, I can pull a 2 out. Watch. Excuse me, I don't know what's going on with my voice today. Let's see, half of 38, I believe that's 19, like that. Okay, so I can pull the 2 out in front, x minus 2, x squared minus 19. And I'm really hoping that everyone in this class is now comfortable with the idea that that is a difference of squares. Now, I realize that 19 is not a perfect square, but I've talked to you about this before, that when you have any number, you know, like if we had, you know, x squared minus 9, I think everyone in here, I hope everyone in here is comfortable with the fact that that's x plus 3x minus 3, difference of squares. What you need to see is that this number 3 is really just whatever that number is, 9, it's the square root of that number. So if you take 9, you take its square root, you get 3, that's what goes here and here. You can use that same method, take this 19, take the square root of it, which is not a nice number, but it is a number. So I'm going to rewrite this as 2, x minus 2, and then I'll have x plus something and x minus something, but again, because it's not a nice number, I'm just going to put plus root 19 minus root 19. And that is our completely factored polynomial. Questions on this? Sure, we're good. Let's see, let me make sure I did the use the use the zeros to factor f over the real number. So we have factored it completely. So we're done. Okay. Same exact thing. So what do you think? You want me to let you try this one? It's the same problem. Do you want me to let you make the lists and come up with everything and go to your synthetic, or do you want me to go through it? What do y'all want? I see Isabella, I think, wants me to go through it. Y'all okay with that? Okay, I'm going to do it. So here's 11. I take the number in the back, 11. All the factors of 11 are just 1 and 11. That's nice. The number in front is 13, and 13 is also a prime number, so there's only the 2 factors, 1 and 13. So I'll take my final list. I'm going to do these numbers over this first, plus or minus 1, plus or minus 11. And then I'll take 11, and I'm sorry, and then I'm going to take those and put them over 13. So plus or minus 1/13, plus or minus 1/11. And that's it. That's my whole list. I have 8 potential zeros. Now my synthetic, make sure I don't have any gaps in here. I have a 13, I have a 12, I have a negative 144, I have a negative 132, and I have an 11. That sucks. And you know what? I'm going to cheat here. I'm going to make a copy of this because I'm going to need it a couple of times probably. Okay, so what should I start with? Probably with 1. 1, 13, that's 13. Add down, we get 25. That's 25. Let's see, if I subtract, what am I going to get there? 24, 39. So I think, I'm sorry, 29 negative. I can't do any math right now. Negative 119. Is that right? My brain doesn't want to work today. Yeah. And then multiply that times 1, that's going to be negative 119. Do y'all see this is not going to work? This is going to be a huge negative number here, like negative 251 or something like that. And then when I put that here, there's just no way. It's not working. Let me try negative 1. 13, negative 13. Add down negative 1, that gives me positive 1. This gives me negative 143. This is positive 143. This is looking good. This is going to be 11. And then negative 1 times that is negative 11. There it is. We got it. Second try. So this becomes x plus 1. And then look at this thing here. This is going to be, let's see, 13 x to the third minus x squared minus 143x plus 11. Okay, we have not run into a problem like this yet. Okay, this is the first time we've had this happen. Do y'all agree? Like this, what's left here in yellow is not something that we can factor easily, right? I need to figure out if I can break that down. So pay attention because this is an important step. What I'm going to do is I'm going to do the same method we just did, just like this. I'm going to do it on this part in yellow, which means I'm going to do a synthetic division. I'm going to do it over here. I'm going to do a synthetic division on the yellow part, 13, negative 1, negative 143, and then 11. And here's the nice thing. You can just continue using the same list of numbers. Okay, so if this yellow one breaks down, its list, the list that we would have to create for this, is identical to the list that we started with. And so what we do is we continue using this list. 1 didn't work, so 1's not going to work here either. All right. And then we use negative 1 and it did work, right? So you would think, okay, now I move on to 11, right? You think, oh, let me try 11 now. You actually have to try negative 1 again because it could work twice. You could have what's called a double zero or something. So I am going to try negative 1 again. 13, negative 13. It's not going to work, I don't think. Yeah. 14. Yeah, this isn't going to work. So now I'll move on to 11. Right? Because that's the next number in my list, 11. 13, negative 1, negative 143, and 11. So let me try 11 here. 13 comes down. All right, I just don't want to mess up my math here. 143. Add down, we get 142. This is not looking good. 11 times 142. Wow, 1,000. Yeah, this isn't going to work either, is it? Do y'all see this isn't going to work? The numbers are just too big. Okay, so what's my next number I should try? I don't want to do it there.
Negative 11.
Negative 11. It's probably not going to work. Let's see. Okay, 13 comes down. This is negative 143. This is negative 144 times 11. Again, this is going to be a huge number. Do y'all see this is not going to happen here? I'm going to stop. You can check it for yourself. That's not going to work. So I've done one, I've done both of these, I've done both of those. Now, which one do y'all want to do? Do y'all want to do the 1/13 or 1/11?
1/13.
1/13? Let's do it. 13, -1, -143, and then 11. So I'm going to do positive 1/11. I'm sorry, 1/13 is what we're doing first. And do you see why 1/13 seems like a good one to go with? Because look at our first number, it's 13, right? So when it comes down, 1/13 times 13 is 1. Understand? Add down, you get 0. That's great, because when we put a 0 here and multiply that times 0, we get 0 here. Add down, we get -143. And I believe when you do -143 and you divide it by 13, yeah, you get -11. Beautiful. Oh, -11, which is 0. So we're really happy about this, right? This tells us now that we have a factor of x minus 1/13. And then here, what's the power on this? The 13 is going to have an x, but what's the power on it going to be? What do y'all think?
Is it squared?
It's squared, yeah, because remember this, everything we've done in black was based upon this yellow piece, and the yellow piece had an x cubed. So we're trying to break this down, and it becomes then 13x squared, then no x's, and then -143. And this is actually what this becomes in yellow. So I'm going to rewrite this like this, and then I had in front of it, don't forget the x plus 1 that was in front of that. Okay, so all of this in yellow came out to be this in black. And just like we did in the previous one, let's see, I think we can pull a 13 out of this, right? 143 divided by 13, that's 11. So I'm going to pull a 13 out of the, last one here. That leaves me with x squared minus 11. And then this again in green here is a difference of squares. I can write that as x plus something, x minus something. I'll put the 13 out front. So here it becomes x plus square root of 11, x minus square root of 11. And this would be okay as an answer. We have completely factored the polynomial using the rational zero test, right? Making a list and using synthetic division. I can't overstate how powerful this method is for factoring, because really once you get past quadratics, or maybe like 4 terms, like fourth degree polynomial, like sorry, 4 terms. So once you get past 4 terms, see this has 5 terms. Once you get to like 5 terms, 6 terms, 7 terms in a polynomial, the only thing we really have is this. All right. So it's extremely useful. Questions? There's
I have
something.
a question.
Yes.
So for the list of the potential zeros, I understand like how you got the 1, 11, 1/13, but how do you get like 1/11?
Oh, shoot. Hold on. I think I wrote that down wrong. I did 1/1, 11/1, and then I was supposed to do 11/1. That's 11. What the heck did I do? I need to do 1/13 and 11/13, didn't I? Thank you.
Yeah, I was gonna ask the same question. I was like, maybe I wasn't paying attention.
Okay, no. This is supposed to be 11/13. All right, I'm not going to make excuses for that. That's an error on my part. But I will share with you all. You know, life happens to all of us, right? We all have a lot of things going on in our lives. This week has been exceptionally difficult for me. I'm not making excuses. I mean, that's just, but my mind is elsewhere right now. So in the past 7 days, I've been to 2 funerals, and I had to put my dog to sleep the other day, like about 3 days ago. Had him for 9 years, and it was unexpected, kind of unexpected. So it's just, my mind is out. And anyway, my dog has his friend. We call him his brother. It's not really his brother, but they've been together for 9 years. And so now I'm having to deal with a dog who's lost his friend, right? So he's right down here next to me right now, and he's been like totally stressed out. So my mind is like all over the place right now. So I think that explains why I'm just not completely focused. So I apologize, but if I do something stupid like that again, just point it out. Because it happens. We're human, right? We're all trying to get through. So, okay. Thank you for pointing that out. Now, fortunately, we didn't need it, right? Fortunately, we were able to get it with the 1/13, so it didn't come back to haunt us. But the next one would have been the 11/13. Okay, what else do I want to say about this? Oh, right here, I noticed something that, like, this in the box, that's done. Okay, it's factored, but there is something that the online system might show you that it's a different correct answer. They may take that 13 and multiply it into this parentheses. And you can see why they would say that. If you just take the 13 and push it into this second one, you get a 13x minus, and then the 13 hits the 1/13 and becomes a 1. And it's just a slightly different kind of look. It's the same answer though, okay, everyone? It is exactly the same thing. But if you were to look at the answer and be like, well, how did they get 13x minus 1? That's what they did. They pushed the 13 through this one. Okay? I just wanted to show you that.
Do you think like on the homework it would want us to push say this
The
equation?
homework should accept this, okay? The homework should, because the system is smart enough to know, I think, smart enough to know that these are equivalent expressions. If for some reason it counts it wrong, let me know. But keep in mind, on a test, I'm just looking at your handwritten work. So, I would accept this. We wouldn't have any issues at all. So don't get frustrated by the computer. Okay, we're moving on. Questions? No? All right, so now we have another problem, exactly the same, okay? But I'm going to add something to this. Instead of doing their instructions, use a rational zero to find blah, 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 blah. I want to see if we can't just sketch this. There's a polynomial function. Can we sketch it? So this goes back to what the whole goal of this all was. And this was actually 2 classes ago when I said how to sketch a polynomial function. We said first we determine the end behavior, and we use this leading coefficient test to figure out what's happening to the edges, right? Up, down, left, right. We look at the degree of the polynomial, and we look at the leading coefficient, okay? Then we find the x-intercepts, and to do that, we have to set the function equal to 0 and solve, which meant we had to factor, and that factoring can be tough. And we also have to determine the multiplicities of each of the factors to determine if we bounce or cross. Does that all look familiar? I mean, it's been like 2 classes ago, but I'm now going to come back to this. Let me just go ahead and copy this page, and I'll pull it over to our notes for today. Let me just paste that in. Ooh, wrong day. Let me paste that in there. I've been telling people, like when you lose an animal, like, sometimes people are just like, yeah, they can handle it and stuff. But man, I'm telling you, I liked my dog more than a lot of humans, and I'm sure people feel the same way I do about their pets, and you don't realize how much he was an indoor outdoor dog. So he was a real small dog. So you don't realize how much, they follow you around, and they, you're their everything, right? And you don't realize that when they're gone, that like, wow, that's a huge piece of you gone. So, I'm surprised with the grief that I've had to go through. It's worse than the funerals I had to go to. So anyways, if anyone has lost a pet recently, I haven't lost a pet since I was probably 12. So it's been a long time. So if you've lost one, you know, my condolences, because it sucks. All right, let's do this. So let's start out. This is a polynomial function. The first thing I'm going to do is the leading coefficient test, right? So I'm going to identify the degree of the polynomial, and I'm going to find the leading coefficient. So the degree is the highest power of x that I see, which is 4. And the leading coefficient is the number in front of that, which is a 1. Any questions there? We're just looking at the number 4 here and the number 1. The question is, what do we do with that, right? So that goes back to this table. And we say, okay, if the degree is even, we're going to look here. If the degree is odd, we're going to look here. So we have an even degree, right? The number 4. So it's going to be one of these two. Our leading coefficient was 1, which is positive, which means we're going to be looking at this situation right here. So back to this. I know that this is an even number, and I know that this is a positive leading coefficient. So I know the left side goes up and the right side goes up, and in the middle, I'm not sure what happens. First, that's the first step. The second step is for us to find the x-intercepts anywhere where the graph has, you know, dots on the x-axis. So to do that, I've got to take the entire function and set it equal to 0. And unfortunately, that's not a linear equation, or it's not anything easy, right? I can't factor that like easily. So I'm going to have to go through this whole process over here on the side to see about if I can break that thing down. Now, the good news is that the number in back is 12 and the number in front is a 1, right? And I told you that if you ever have a 1 in front, then your list, your final list, is just the list for the back number. That's all it is. Right? Because you would really be doing this, 2 numbers like this. And then because this one's plus or minus 1, that's the only thing here. It's going to be this list divided by 1, which is just the original list for 12. So really all I have to do is figure out the list for 12. So 1 and 12, 2 and 6, 3 and 4. Yeah, and that's it. I've met in the middle, so I'm done. Questions? Synthetic? Let's see, 1, 2, -7. I don't have any gaps here, right? I have something for every power of x, so I'm just being careful I don't have any zeros in here. Okay, what in the world? Let's start with 1, I guess. Please work. Oh, are we going to get this lucky? First one. Let me double check. 1, 1, 1, 3, 3, -4, 1. Yeah, it works. Okay. I know I'm going through that fast, okay, but I'm trusting that you could do that, you know, given a little more time. So this tells me that it can be broken down to be x minus 1. And then because we started out with the 4th degree, this is going to be x cubed plus 3x squared minus 4x minus 12. Okay. By the way, I should mention that if you have 4 terms, okay, if you have 4 terms here, you can always try to do grouping for the factoring. If you've learned grouping in the past, you can try grouping. Grouping would actually work here, but I'm just going to continue with the synthetic division because that's what this is all about. I'm going to take this, do that in a synthetic division box. And I'm going to continue with my list, and I do need to check 1 again. Okay, 1 worked, but it could work twice. So I'm going to try 1 again. I don't think it's going to work. No, didn't work. My remainder was not 0. Does anyone have a question as to what I'm doing here? Does anyone know what number works? Want to save me some time?
-3.
-3, thank you. So we would have had to have done 1, -1, 2, -2, and then you said 3 or +3, Diego? Negative. I'm sorry, negative?
Yeah, negative.
-3. Okay, so Diego's going to save us some time here and go right to this. So let's see, 1, then we get -3. That's 0. That's 0. Add down -4. Negative times negative is positive. There's +12. There's 0. We're completely happy to see this. This gives us x plus 3. And then here, again, because the yellow one started out as cubed, this 1 is going to be in front of an x squared. I have no x's, and then I have -4. And then when you look at that, you should be, oh, that's difference of squares, right? That becomes x plus 2x minus 2. Now, keep in mind, this right here, okay, that we just got is just this part in yellow. So I'm going to come back up here, right? This is just the part in yellow. Kind of keep this a little separated. This was my other synthetic that I did there. So this part in yellow broke down to be this. Do not forget that we still have the x minus 1 in front of that, right? So right here, underlined in green, that is our completely factored polynomial function. So I'm going to come back over here and I'm going to say x minus 1 times x plus 3 times x plus 2 times x minus 2 equals 0. And also, I'm just doing a quick check to make sure none of these are the same. Like, let's just say, for example, okay, let's just say that this one would have been, I'll do it in red. If this was an x plus 2 as well, if these were both x plus 2s, then I would put x plus 2 squared instead of x plus 2 times x plus 2. And the reason I would need that is for the multiplicity. This would help me with the whole idea of bouncing and crossing. But because they're different, I'm not going to worry about that. But I did check real quick to make sure I didn't have any of these things repeated. We good? What do we do? What do we do now?
Set all of them equal to 0.
Yep, set all of them equal to 0. Okay, so when we set them equal to 0, I'm just going to put what the answers are. We get 1 here. We get -3 here. We get -2 here. And we get +2 here. So we know where on our graph we have x-intercepts. What we need to do next is determine whether or not we bounce or cross at these x-intercepts. And that was called the multiplicity. And hopefully you remember what we did to do that. You go back up and you look at the powers on each of these factors. And for this particular problem, the powers on all of these are 1s, right? And what does that tell us is going to happen? Whenever you have, well, we have a 1, that's an odd number, right? Odd means we will do what there? Do I remember? Multiplicity. Determine the multiplicity of each of the x-intercepts. If the power is even, we will bounce or touch off the x-axis. If the power is odd, we will cross. All right, so we have all of these are odd, aren't they? They're all odd numbers, odd. 1 is odd, 1 is odd, 1 is odd. So that means here we will cross, here we will cross. I'm putting a C for cross, cross and cross. Do not make the mistake of looking at the actual number. I'll have students that'll be like, oh, here, look at 2. Oh, 2 is even, I must bounce there. No, You're not looking at that number to determine the bounce across. You're looking at the power on the factor that created that x-intercept. Any questions on that? Time to draw the function. I will start by putting my x-intercepts. Let's see, -3. I have an x-intercept. At -2, I have another x-intercept. At 1, I have an x-intercept. And at 2, I have an x-intercept. Okay, those points definitely exist on my graph. The next thing I'm going to do is remember what the end behavior has to be. Both sides, left and right, have to go up. So that means from this point at -3 to the left, my graph has to go up. And then this point on the right, 2 to the right of that, it's got to go up as well. And now what I need to do is just connect the dots with a smooth, continuous curve, right? That's what a polynomial function looks like. And when I get to these x-intercepts, I need to cross through all of them. So when I come down here and I get to -3, I need to cross through the x-axis, actually go down through the x-axis. Then I need to turn back up and go through this x-intercept and cross through as well. And then I need to eventually come back and turn through here and cross through. And then turn through here and cross through again, and then just try and smoothly connect these together. There we go. We're done. I had told you before that everybody's picture is going to look slightly different. Like somebody could do this. Okay, someone could have drawn this. And that would be correct. We all have to have certain things that look the same. Like we have to have our left and right hand sides go up, right? That has to happen. We've got to have the up on the left and on the right. We all have to have the same x-intercepts. We all have to have that we cross through. So that means yours might go like not that far down here. Yours might go real far down. It just depends on how you want to draw it. Same with between -2 and 1. Both of our graphs must be above the x-axis, but how far you go up and how you waver around, that's up to you. And did I tell you that you'll figure out how high this goes? You'll figure out this part in calculus. Did I tell you all that last time? Like that in calculus, that's where you figure out where those peaks and valleys are. But in this class, all we can do is find the x-intercepts, the cross and the bounce, and the end behavior. That's all we can do here. And it's still a lot, right? I mean, we have a lot to handle here. Questions? We're good? Hold on. Okay, I want you to work on this one yourself. Okay, graph this polynomial function. So you're going to go through all the steps we just went through, figure out the end behavior, all that stuff. Here's what I'll do. I'll take this, I'll copy it. I'm going to put it on this page with the notes on how to do it. Just pop it in right here. I hope that's good enough. Is that okay? All right, let's take some time. Why don't you let me know in the poll if you complete it. I need to work the problem myself. I haven't done it. You know what? Let me check it before I send you all off on this and then it winds up being some disaster. Let me just check it real quick to make sure. You can go ahead and get started with it though. Ooh, okay, hold on. Hold up a second. That ain't gonna, that's not what I want. let's do this instead. Let's do this one. I know this will work because it was a test problem. So scrap that, sorry. Do this one. You know, see that? Sketch, I want you to sketch this function using the methods that we just went through. A quick hint for you on your step here where you're finding the x-intercepts and you're setting it equal to 0. When you set that equal to 0, everyone, before you start doing your synthetic division, pull a GCF, greatest common factor, right? All of these have something in common, don't they? Pull that out before you start your synthetic division. All right, see how it goes. I'm going to launch the poll. If you do finish the problem, you let me know. I'm guessing this will take at least 10 minutes, at least. So have at it. All right, everyone, it's been about 5 minutes. I'm going to start working the problem out, but just silently, so you can kind of look up at it and see if you're getting the same thing. Okay, I've finished. I'll leave my work up here. I've got 5 of you say you're done. Make sure that that looks like what you have. We'll talk about this in just a few more minutes. I'm going to go 1 more minute and then we'll talk about it. Okay, let's discuss this. So were there any questions over the work that I have here? Those that have had a chance to look at this. Degree, leading coefficient, left side down, right side up. You also understood what I meant by the GCF, pulling out that x squared to begin with. Then doing synthetic off of this yellow part. And then once you're here at this blue part right here, you have 2 choices. You can continue with the synthetic, which I skipped a bunch. I went right to what worked. I knew that the 4 would work. But if you wanted to, you could just factor this using like your AC method. You know, this is a quadratic. So you just say, oh, I need 2 numbers that multiply to be -28 and add up to be 3. So you can say, oh, x plus 7, x minus 4. That's fine if you do that on the test. That's perfectly fine with me. But just in case you couldn't, you could use this method as well. Once you get all your factors lined up, you set them each equal to 0. And then you look at the powers on each factor and determine whether or not you have bouncing or crossing. The only one that's even is this first one, x squared. So that's going to be a bounce at 0. So then here's what the drawing should look like. Are there any questions on it? Sure, we're good. Here's what it looks like on a computer. Whoa, what the hell just happened? Give me a second, I lost all my screens here. There we go. Okay, so here's what that graph looks like on a computer, which looks a lot different than ours, right? But I'm going to change something on it so you can see that we do have the right picture here. I'm going to just kind of squeeze all this down. See, our graph goes down on the left, it goes up here, right? And then right in here, it's really hard to see this, but there's our bounce, right? We come through -1, we bounce off 0 and go back down. That's exactly what we have here. It goes up, comes through -1, bounce off 0, come back down, go back up. Okay, we good? I only have 10 more minutes. I wanted to show you one more type of problem. Let's see here. This one right here. Look at this. I'm asking you to sketch this polynomial function, all right? Notice that I have already given it to you factored, right? I've given it to you factored already, which is great because you don't have to go through all the synthetic division and all that stuff, right? Do y'all agree? You could just like set this, if I wanted to find the x-intercepts, I could set this equal to 0, I get 0 here, set that to 0, I get -7 there, set that to 0, I get 2 here. And then if I look at the powers, that's a 1, this is odd, 6 is even, and this is odd, right? So I know that I'm going to cross here, bounce here and cross here. So I know, I mean, just by giving it to you in that form, there's a lot you already know without doing much work. Do y'all agree? The thing you don't know though is the end behavior, the leading coefficient test, right? The leading coefficient test. You don't know if it's going to go, you know, up on both sides, down. It's not obvious. When you're given a problem like this, you just look at the degree and the leading coefficient, that you get that off your table. So there's kind of a give and a take here. Here I've given it to you factored, so it's easy to find the x-intercepts. It's easy to determine bounce across, but it's not easy to find this thing. But actually, it's not that bad. Watch. This is how we do it. You look at the to do the leading coefficient test, right? That's our x-intercepts. We're already done with that step. But for the leading coefficient test, let's just look at this thing. The way you do this is actually pretty simple. You look at each of the factors and you look at what the biggest power of x you would get out of them is. Let me explain. X is just x to the first power, right? That's x to the first power. Times, now if you were to take this and multiply that out, x plus 7 times x plus 7 times x plus 7, right? Times x plus 7 times x plus 7 times x plus 7. You would not want to do this, right? This would take you a long time. It would be a pain in the butt. But what would the highest power of x be if you did this? What would be the highest power of x you would see? What do you think?
Is it to the 6th?
Yeah, to the 6th. Because it's to the 6th power, the highest power of x you're going to see here is x to the 6th. Now, there's going to be a bunch of other stuff, but the highest power you see is x to the 6th. And then what about this one? What do you think? The highest power of x you're going to see here would be what?
Cubed.
Cubed. Okay, so you have an x to the first power, an x to the 6th, and an x to the 3rd. If you were to put these together, you would add the exponents. X to the 1 plus 6 plus 3. This is going to be the same as x to the 10th power. In fact, a 1x to the 10th power, because there's ones in front of these. So if you look at this, that would be the highest power of x that you'd see, and that would be the leading coefficient. So you have the degree here would be 10, which is even, and you'd have a leading coefficient of 1, which is positive. And so you know it'd go up. And in the middle, you don't know. Do you see how we do that? You're just going to look at the highest powers on these x's to determine what they all would add up to be. And now you can draw it because you know what happens here. Let me see. I'm going to try and squeeze it in right here. So for my graph, I now have an x-intercept at -7, at 0, and at 2. I know the left side goes up, the right side goes up. And then back up here at -7, I'm going to bounce. So I'm going to bounce off the x-axis there. And then at the other two x-intercepts, I cross. So I'm going to cross through, connect, and be done. That makes sense? Okay, let's call it a day. I was not able to get through every single problem out of the homework. There's, let's see, which ones did I not do? I didn't do this one. It says find the real solutions to the following. So this is basically, you're going to factor this. You're going to, do your synthetic division and try and break this down, then set each factor equal to 0. Okay. Same with this one. This list is going to suck. And then graph and graph. Yeah, see how it goes. You might have questions. That I think there's 1 or 2 in there that are going to be a little weird, but see how it goes, and then come back next time with questions. We can go over any of these if you want. Okay. All right, we'll call it a day. Everyone have a good one. We'll see you on Wednesday.
Thank you.
Thank you, you too.